Hi everyone. In this video, we are going to prove that square root of 2 is irrational. Now let's first try to understand what a rational number is. A rational number is such a number that can be represented as a ratio of two co-prime numbers. Now what is a co-prime number? Well, co-prime numbers are such pair of numbers that have no common factor other than 1. Right? For example, if I say 3 and 4, they are co-prime numbers. How about 6 and 4? Are they co-prime numbers? No, because they have a common factor 2. However, if we say 9 and 10, they are co-prime numbers, even though they themselves individually are not prime number, but they as a pair, they can be called co-prime numbers. So to represent a rational number, we need two co-prime numbers, or every rational number can be represented as a ratio of two co-prime numbers, right? So now let's assume that square root of 2 is a rational number. First, we are going to assume that square root of 2 is a rational number, and then through contradiction, we will prove that it is actually not a rational number, it is an irrational number, right? So initially, let's take that square root of 2 is a rational number. So square root of 2 is a rational number, and we are going to express that as a ratio of two co-prime numbers. Now if those two co-prime numbers are p and q, that means p and q have no common factor other than 1. Well, 1 is a common factor for every number, so let's disregard 1. But other than 1, there should be no common factor between p and q. Now with that assumption, let's proceed and see what happens. So now I'm going to square both sides of this equation. By squaring, we get on the left side, we get square root of 2 whole square is equal to p by q whole square. And from here, we get 2 is equal to p squared by q squared. And from here, we get 2 times q squared. If we do cross multiplication, 2 times q squared is equal to p squared. And from here, we can say that p squared is equal to 2q squared. Now, if you look at it, the square of p squared has a value which is even number. Why? Because 2 is a factor here. So, because 2 is a factor, the square of p or p squared is actually an even number. So, this is an even number. Now, if the square of a number is an even number, then the number must be an even number. Why? Let's take a few examples. Suppose we take an even number and we square it, we get 4, which is an even number. But if we take an odd number, we square it, we get an odd number. Similarly, again, if we take another even number, suppose 6, we square it, we get 36, which is an even number. But if we take, say, for example, 5 and we square it, we get 25, which is an odd number. So you can see that if the square of a number is even, then the number itself must be even. So in this case, because the square of p is looking like an even number, that means p must be an even number. So from here we can say, okay, if p is an even number, let's represent p as 2 times of some other integer k, for example, right? So let's assume that because p is looking like an even number, let's assume that p is 2 times k, right? So from here, we are going to modify the equation a little bit, and now our equation going to look like this. So from here, we can say in place of p, we are going to write 2k whole squared is equal to 2 times q squared. And from here, we can say 4k squared, 4 times k squared is equal to 2 times q squared. And from here, we can say if we divide both sides of this equation by 2, then on the left side we get 2k squared is equal to q squared. And from here we can say, okay, so q squared is actually equal to 2 times k squared, right? Now here again you see the square of q is also looking like an even number because we have 2 as a factor here. So that means the square of q or q squared is also an even number. That means q itself must be an even number. Otherwise, its square cannot be an even number. We already saw that from the examples, right? So if q squared is an even number, that means q must be an even number. So now let's assume that q is equal to 2 times of some integer m, for example, right? So now we see that q is an even number and p is also an even number. So from these two boxes you can see that p and q, they have a common factor, which is 2. And initially we assumed that p and q are co-prime numbers and they did not have any common factor. So the assumption that we made, that if square root of 2 is a rational number which can be denoted by p divided by q, and p and q being co-prime numbers, that assumption now has been proved incorrect, because now we are at a situation where our assumption kind of contradicts the result that we are seeing. Here we are seeing that p is an even number, q is also an even number. That means p and q, they have a common factor, but initially we assumed that they do not have a common factor. So our assumption was not correct. That means the assumption that square root of 2 was a rational number, that assumption was not correct. So now we have proved through contradiction that square root of 2 is actually an irrational number. I hope the proof made sense. Thank you for watching. See you in the next video.